How's it going, everyone? Welcome back to the third CP104 review session of the year. Today we're going to be looking at repetition, and in specific, we're going to be looking at for loops and while loops. This review session is going to be pretty example heavy. So again, if you want to take a look at any of the examples or any of the code at all that's in this video, there's going to be a link in the description to a GitHub page where you can take a look at all of the code snippets that are going to be used. So yeah, let's just get started with the syntax of for loops and while loops, and then we can move on to some examples and scenarios that we can use them in. Okay, so beginning with the for loops, because it's the simpler of the two, pretty much what a for loop is you define how many items you want Python to repeat, how many times you want it to repeat, and without fail, it'll repeat that many times. So we start off with the keyword for, and Python then wants us to give it an increment variable, something that gets updated every time the for loop runs. So let's just call that increment for now. Usually we call this a single letter variable just because it's easier. I is the most common. So let's just keep it at increment now, just so it makes it easier to understand. Then we still haven't learned about lists or strings. So the only thing we should really do with while loops right now, with for loops, is the range operator. So we say for increment in, so this means within, and then we get the range operator. And so the range operator is called a constructor, and it constructs an iterator class. And so what this iterator does is it creates a range between some number to another number. And we can pretty much go through that number, setting the increment to the next value every time. And yeah, that's pretty much how our for loop is going to be working. So we have to give this a start value, an end value, and then an increment as well. So sorry, let's just change this to I so we don't get confused by these two because they aren't the same thing. And then after that, we have our statements. So our range, this for loop is always going to go from the start value to our end value -1. And then by default, it's always going to go up 1 every time. So if we don't include an increment, this increment is optional. It'll go up by 1 if we don't include it, and then we can include any number that we want. If we include a negative number, we have to make sure that our start value is greater than our end value, or it's just not going to run. And if we do have our start value greater than our end value with a positive increment, it won't run as well because the range iterator won't have anything within it. So that's pretty much the syntax for for loops. This is how we use it every time. We always have the increment variable. We always use the range. We specify start value and end value. We always remember that the end value, or this range, ends at end value -1. So even if your end value is like -10, you're going to be ending at -11. So just keep that in mind. And then we include an increment if our for loop requires that, if the context of our problem requires that we have a different increment than 1. And then the statements that we want to repeat however many times. Okay, so that's pretty much all there is to know about for loops. So let's take a look at while loops. While loops to some students are more intuitive, but to a lot of students, they're less intuitive. So how we want to use a while loop is pretty much just like this. While condition, and then statements. So this condition is similar to any of the conditions that we used in our if or else statements. So any of those Booleans, true or false. So let's say, for example, 5 is greater than 10. This is going to return false. So this is never going to run. But if it's 10 to 5, for example, this is going to keep running forever because 10 is always going to be greater than 5. But let's say, for example, we want to count up to a certain number. So we give it an I value as well, just like the increment. So we set the increment up to 0. And then let's say while I is less than 10. So if you see here, this is still going to have a problem because I is just going to remain at 0 every time. So this is where we kind of include that increment value from the for loop. So we can say I is equal to I plus 1. And so every time we go through this while loop, we're also going to be incrementing I by 1. So this while loop is going to run 10 times. So essentially, that's all there is as well to while loops. The syntax is very simple, but this is pretty much the diving board into the deep end of programming, and understanding loops is really going to be very crucial going forward. So I'm going to take us through some examples now that'll really help you get a grasp of how loops work and in what scenarios we have to use them. Let's look at our first example here. It's called number staircase, and we need to implement a function that prints numbers in descending order from start to end that decrease by increment. So we have 3 inputs: a start, which is an integer. This is the number that we're starting at, so the top of the number staircase; the end, which is the ending number or the bottom; and then the increment, which is the number to increment by. And so we can start this off. Obviously, the most intuitive way is going to be using a for loop. So we can say for num, or for number, or for I. It doesn't really matter, again, what you use here. I is the most commonly used syntax, so let's just go ahead and use that. For I in range. So we know that our top, like our starting value is going to be start, so we can say that, and our ending value is going to be end. And then right now, our increment is going to be a positive integer. So if we want to increment by 2, like going down by 2, we have to say negative increment. So what this is going to do is, sorry, I forgot the in operator. There we go. It's going to go from our start down to our end by increment. We're going down because of this negative right here. So then we know that we just want to print this, and we can just print I. So this is the most intuitive way of doing it. But we can also use a while loop, which some people might find more intuitive, but personally I find it's like a little bit more difficult to understand for a context like this. But let's go ahead and do that so we know how to convert. Let's just keep this here, actually. So we can say that so we know that we want to start at start. So we can say that I is equal to start because we want our I value to begin at start. And then we can say while I is greater than end. We say greater than because we want to keep going until our I hits our end. So that means we know that we've printed all of the numbers from start until end. And then we can say print I. We also have to do one more thing because we're using a while loop that doesn't update this I. That's an important thing to keep in mind, that while never updates anything in your condition like the for loop does. So we have to say I equals I minus increment. So now we have 2 solutions to this problem, one of them using a for loop and one of them using a while loop. So the for loop initializes an I variable and then makes a range from start to end using a negative increment because we're going down, and then it prints out the value. While on the other hand has to define an I value first and say the condition being I is greater than end. Then it prints out our current number and then it decrements it. So that's how we do this problem. Let's move on to the next one. Okay, so here's our second example. Pretty much all we have to do is print all of the factors of a given integer n. So let's start off. We obviously need a loop to do this, just to loop through every possible factor and then check which ones are going to be actual factors that return integers when dividing our integer n by that number. So again, we can say for I in range, we can start it off at 1 and then go up to n, because we know that 1 is the lowest possible factor that we can have for n, and then n, of course, being the highest possible. Again, let's remember that this range operator goes up until this value minus 1. So if we want to include n in the factors that we print, we have to say plus 1 here. So this will go all the way from 1 up until n, not up until n minus 1. So then we have to check if it's divisible. So we can say if n is divisible, this is the modulus operator. Let's just see how this works in just a second, by I is equal to 0. So what this modulus operator does is it takes the left-hand side, divides it by the right-hand side, and then returns the remainder. So this gives us the remainder between this and this when they're divided. So if the remainder is equal to 0, we know that this, our n in this case, is divisible by our I. So that means that this is a factor, and we know that we have to print it. So we print I, and there we go. We found all of the factors. We went through every single number between 1 and n. We checked if it was divisible, and then we printed it out. So let's run this really quick. Let's see what happens. Print factors, oops. Let's say of 20. Let's run that. And we can see 1, 2, 4, 5, 10, 20. So those are all the factors. All right, so again, let's try completing this with a while loop instead. So we can set our I value equal to n. So we know that, or rather, sorry, our I value equal to 1 or 0. We always want to set our I value to whatever we'd have in our starting value in the for loop. So we can say I is equal to 1. And then we can say while I is less than n, so we're going up this time, so our I cannot exceed n. We say if, again, oops, we get the condition as well. If n is divisible by I, then we print out I. And regardless if this condition passes, we want to increment our I value. So I is equal to I plus 1. And there we go. So this again will do the same thing. So let's try that. Print factors of 20. And there we go. Well, in this case, as you can see, we missed that 20 because our I is only going up to n minus 1. So to fix that, of course, we got to add the equal sign. And there we go. We got that 20 there. So that's how to do it with both a for loop and a while loop. Let's move on to the last example. All right, so here's our last example. It's called employee payroll, and we want to calculate and return the weekly employee payroll for all employees in an organization. For each employee, we get an ID, an hourly wage rate, and the number of hours they worked for a week. And an employee number or employee ID of -1 indicates the end of user input. So each employee is paid 1.5 times their regular hourly rate for all hours over 40. So before we start our loop, we want to ask the user for an ID. We do this because we know that it's our condition. If we get an ID of -1, we don't even want to iterate. So obviously we want to collect the ID first just to make sure that we can continue with the loop. So we can also say while ID is not equal to -1. So this loop is only going to run for any values that are inputted by the user that isn't -1. So we also want to return total and average. So let's initialize a total variable outside of the while loop. This is because we want our variable not to be updated back to 0 every time. We want it to be like a running counter so that we can add to it inside of the while loop without setting it back to 0. If we initialized it within the while loop, it would get set back to 0 every single time, and it wouldn't be accurate to the proper total. It would be like a local maximum rather than like the global maximum. So then we also need a number of employees to calculate the average. So next we have to collect the rate. Again, it's another integer input, hourly wage, and the hours worked as well. we're just assuming that these are all integer values. Like, of course, they could be floats. You just have to change this int to float. But just for simplicity, we're making it integers. And so we know that overtime is going to be any hours over 40. So let's calculate that. Overtime is equal to hours minus 40. And our net payment is going to equal rate times hours. The reason we don't add overtime is because with doing this, this could be negative or like 0. 0 wouldn't really matter, but negative would mess up our calculations. So let's check for that condition before we add it. If overtime is greater than 0, then we say net payment plus equals, this is just saying net payments equals net payment plus. It's just a shorthand operation in Python. Overtime times rate times 1.5. So we're adding the overtime to the net payment if applicable. And then we have to say, we have to update our total equals net payment. And then our number of employees gets increased by 1 because we've collected data for 1 employee. All right. And then we just have to collect the ID again or actually let's print out something as well to just say our employees net payment. So let's say net payment for employee with the ID is going to be net payment. There we go. And then we can also say that we just have to get the ID again, and then the loop starts again. So once they enter -1, we know we have to break out and then return total and average. So once we get out of the loop, let's say return total, total, and then total divided by number of employees. So that is our whole function. So what we do is we grab the ID, we loop until we get an ID that's -1, and then we stop, and then we return total and average. And we're collecting that through the rate that's given to us by the user, the hours, and then we just do some calculations here, and then we add it to the running total. So let's see how this works. So let's call the function employee payroll, and let's go. So it's asking for our employee ID. Let's just say, oops, I typed in the wrong spot. And let me clear out my terminal so it's not as, there we go. 1, 2, 3. Let's say our hourly wage is 40 and our hours worked are 10. So obviously the net payment is 400. Then let's say 4, 5, 6 for the next employee, 35, 36, and let's say they worked 75 hours. Bunch of money for them, and then let's just say -1. And I forgot to print out the results, so let's do that, and let's do it again. All right, let's do the same thing. 1, 2, 3, 40, 10, 4, 5, 6, 36, 75, and -1 here. And there we go. So we added these two, and then we get the average as well. So I hope you guys enjoyed this review session. We'll be back in the next couple of weeks for our second last review session. And yeah, make sure you check out any of the code snippets in the GitHub link below, and ask any questions in the comments. I'll be looking at the comments to answer them. And yeah, I hope you guys all have a good day. Thanks for joining me.